Hello everyone, and welcome to our latest Code Presents webinar, an introduction to large language models, also known as how chat engines like ChatGPT work. We're excited to have Code Senior Developer Dr. Otto Dobretsberger presenting today. Today, Otto is going to talk about how large language models work and how they're utilized by chat engines like ChatGPT. My name is Jim Duffy, and I'm responsible for the marketing and sales efforts for all the Code Group services, including Code Magazine, of course. But the Code Group is so much more than just a magazine. The Code Group is comprised of 4 primary divisions: Code Consulting, Code Staffing, Code Training, and of course, Code Magazine. Our continuing mission is to help people build better software. Code Consulting provides a number of services, including building custom software solutions on-prem and in the cloud, including web, mobile, desktop, and IoT. We also provide Copilot development and other AI solutions, application security testing, UI design, modernizing legacy applications, and supporting and maintaining existing applications. We also offer AI-specific consulting services to help your organization leverage the power and transformative capabilities of AI. From executive briefings, application analysis and readiness, and proof of concept skunk work projects, our team of expert developers and consultants are ready to help with your projects. Code Staffing is disrupting the world of software development staffing. Our customers get Silicon Valley quality staff, and our employees get to work in a bleeding-edge tech company with industry-leading benefits, including profit sharing. If you need development help, or you're looking for a new gig with a staffing company that actually cares about you, check us out today at codestaffing.com. We are hiring across the entire Code Group, and we need you. Check out our current openings at codestaffing.com/careers. We have a number of events coming up, including our new full-day introduction to development with OpenAI, ChatGPT, Azure OpenAI, and more on June 21st. For more information or to register, head over to codemag.com/training today. Code Magazine is the leading software development magazine written by expert developers for developers. All registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. I've also included a free subscription link here for you to freely share with others who couldn't make it to this webinar. The Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. If you like what you see today, or have seen in our prior webinars, please subscribe to our YouTube channel, follow us on Twitter, like us on Facebook, and follow us on LinkedIn. The slides and recording of today's webinar, and all of our webinars, will be available on the Code Presents webpage on the Code website. All registered attendees will receive an email after the event directing you to the slides and the webinar recording as well. We would like your feedback about the webinar in the form of a quick survey. The survey will be available once the webinar has been underway a bit. We want your feedback, and we're willing to pay $100 in the form of an Amazon e-card to one lucky attendee. A name will be drawn from the list of completed surveys. The survey link is on this slide, and we'll post the survey link in the chat window as well. Our presenter today is Otto Dobretsberger. Otto is one of our senior software developers and earned his master's and PhD in computer science from the University of Houston. His background is in heavy computation, genetic, and genomic data analysis using C and C++. He specializes in WPF, C#, and C++, and is proficient in several other languages as well. He has authored scientific papers, magazine articles, he is a frequent speaker at conferences, and is an adjunct professor at the University of Houston. All right, that's enough for me. Thanks for listening. Take it away, Otto.
Hello, everyone. Good morning or good evening or wherever you are. My name is Otto, and I'm going to talk about generative pre-trained transformers today, and specific about applications like ChatGPT that are built on this kind of technology. We're going to start right in. I hope everything is set up, and I think everybody should be able to see and hear me clearly. So let's get started and talk about large language models. I think pretty much everybody here has used large language models before in one way or another, most likely on your phone. The word prediction that you get when you type a message, when you type an email and so on, is really a version of a language model, but that one is just based on frequencies. And what we're going to do today is we're going to start at that level. We're going to start at the frequency level and see how large language models like GPT-3 and 4 and so on are developed on top of this technology and what else comes into play. We're going to look at examples how this exactly works, examples that we can follow so that everybody gets a little bit of an idea what the magic, so to say, behind these language models is. So we're going to have an assistant here today, Bob Dylan. He's going to accompany us throughout this presentation. And I'm borrowing some of his work for this presentation, some songs or poems for him. And we're going to look at exactly how this technology works on an example from Bob Dylan. So we're going to start with this poem or song that he wrote that basically reads, "You that never done nothing but built to destroy, you play with my world like it's your little toy. You put a gun in my hand and you hide from my eyes. Then you turn on and on farther when the fast bullets fly." And I've highlighted the word "you" here because we're going to, as I said, start with a frequency-based model where we're going to say, okay, based on frequencies, what is a word that we would like to, or on perspective of the machine, that we would like to put after another. And if we look at this poem, we can see that the word "you" is being used 5 times here. Now, if we ask the question, what comes after that word "you," we can look at it this way and say, all right, well, if "you" is our central focus point here, we can say, all right, after that word, we have essentially 5 paths we can follow. We can say "you that never done nothing," etc., or "you play with my world," etc., or "you put a gun in my hand," etc., "you hide from my eyes," etc., or "you turn and run farther," etc. These are the 5 paths that somebody could choose from when you say, all right, my last word that I have written was "you," what comes after? So from a perspective of a generative pre-trained transformer or of a GPT, that is the first step if it was simply and just based on frequencies. And then we can assign weights to these frequencies or edges, right? We can say, all right, every single path has an edge, and we will assign a weight to that edge. And since we are not taking any favorites here, we're saying, all right, every single path is equally likely to travel down. We can say every single path has a percentage or a frequency or a likelihood of 0.2. And now this is done with that little poem that we were looking at, and only with one word, only with the word "you." Now, of course, this would give us not a lot of options if we were to say, all right, we have a model that has been trained on 10 lines of text and we've only looked at one word. So what we essentially would need to do is do the same thing but for other words, essentially for all the words. But for simplistic purposes and for making it a little bit better understandable, we're going to do that just with the word "you" and the word "my." So we're going to do the same thing for other repeating words as well. We're going to choose the word "my" because "my" also is followed by 3 different paths or edges here. We can say "my" is followed by world, "my" can be followed by hand, or "my" can be followed by eyes. And given these 2 constraints, we can now put together a very simple model that we can say, all right, just based on frequencies, just based on what we have looked at so far, what are the chances that if we write something, we are creating a new text that sounds and feels kind of like Bob Dylan wrote it or was involved with it. So if we start with "you," at the very top here, we can create a new song, right? We can say "you," what comes after, right? And rather than following what Bob Dylan actually wrote, we now have a choice to follow a different path. So I have the original down here on the bottom right, and we can say instead of "you that never done nothing," after "you" we go to the word "play," right? So the first sentence could be "you play with my eyes," then "you," and it goes up to "play with my world." Then there's no "you" in the next line, like it's your little toy, But then we have you, and rather than put a gun in my hand, it goes to you that never done nothing. So it goes up to this edge to the word that. It's never done nothing, but builds to destroy. Then we have another you, and this one, rather than continues with play with my world, this you goes to hide from. So we go down here to this path, hide from, but then rather than going to my eyes, it goes to my hand, because the chances or the likelihood to go to eyes is equal as it goes to hand. So we can say you hide from my hand, and right now we have a somewhat okay poem, I would say, right? Somebody who has never heard anything from Bob Dylan would just look at English language and semantics and that sort of stuff, would say, okay, this is okay, you know, in terms of grammar and so on. Somebody who has looked and has heard Bob Dylan songs or poems, maybe not the original, this one, but other works, might say, okay, well, I'm familiar with the way he writes, the kind of topics he writes about. Maybe that does sound like something Bob Dylan, right? You play with my eyes, then you play with my world, like it's your little toy. You that never done nothing but built to destroy, you hide from my hand, right? It doesn't sound totally outlandish. But then we're getting to a point where we have something, and you hide from my hand, and you hide from my hand, and you hide from my hand, right? Because after my, the chances to go to hand are equal as they are to go to eyes. And since my only has 3 edges, each a third likelihood to go one of the 3 words, if we run this often enough, we very likely will get something like this, where we run into a loop where we don't get out of this anymore until the chances are in our favor and we pick a different word after my. But you see that just based on these likelihoods and this kind of stuff, there is a lot of garbage that gets created as well. And there is not really anything we can do about this if we have a limited amount of training data, a limited amount of words that we have run this statistics on, right? Being created these edges for. So yeah, Bob Dylan here we can see is not very amused. He's not very happy with what we have done so far. So we have to ask ourselves, okay, can we improve this? Can we take it to, you know, much higher level and so on? So what can we do? Well, we can train it on more text, right? We can say, all right, rather than having just one poem or part of one poem, we can say, let's take all of his work, all his songs, all his poems that we have written, and do the exact same thing that we've done right now, but with all of the text and all of the repeating words in this text. And suddenly we have a model that is a lot more powerful, right? Now we have a model that says, all right, based on the way this person writes their work, writes their poems and their songs, the kind of things that they use, we will create something that does look or sound somewhat like the way Bob Dylan would write it. Of course, this is in no dimension anywhere near of what the capabilities of ChatGPT are. So we have to go further and say, all right, how do we get something that is now a lot more powerful, right? Because right now we have only trained something or a model on one author, right, or one artist that has written something. We would like to have a more universal kind of more powerful machine to use for our purposes. So we have to go and dive into a little bit deeper and say, all right, well, in our case, we have a probability function that only is based on one word, right? Only on the previous word. We can say whatever we want to pick as our next word only depends on the immediate previous word. And in our case, it's only applied to you and my, right? We need to do better. So we need to have a function that does not just depend on the immediate previous word. We need to have a function that goes further, that has more constraints, that looks at a lot more of the training data than just with a one immediate word before that. So rather than just looking at one word before to determine what comes next, we're going to, or we can, create a table of N-Grams. That means 3 grams, 4 grams, 5 grams, and so on, up to 10 grams, however powerful you want to make it. And of course, however much training data you have and however powerful your hardware is to run this training data on, right? Because this takes time. There is a reason why all of this training takes forever, right? Because it becomes exponentially more difficult to run all of these algorithms. So we're going to create dependencies where we say, well, we're not just looking at the previous word. We're looking at N-Grams. We're creating tables for all 3 grams, 4 grams, 5 grams, and so on, all the way as far as we can afford it by testing it out on our hardware, as far as we can afford it, where we're not waiting 10 years for this to finish. But this is only one application that is, or one constraint that gets created. They get tons and tons of different constraints that are created as well, because such a model needs to understand not just, hey, what comes next, it needs to also understand other contextual constraints. So for instance, I can have a constraint that says, well, we look at not just the previous word to determine what comes next, the previous 3, 4, 5, 6, 7, whatever, n numbers that come next, but we also look, in this case, I've highlighted here, if we want to write this text, we also have a constraint that says it needs to rhyme, because otherwise it wouldn't be a poem, it wouldn't be a song, right? So we have a constraint that says we need to rhyme. Now, this constraint gets a little bit even trickier, right? Because rhymes aren't created based on words. Because there are words that are 1 syllable long, there are words that are 4 syllable long. So you can't go by word number on where it needs to rhyme. So you need to break it down even further and write a constraint that says, all right, in order for a word to be chosen, it needs to rhyme. So we have a rhyming constraint, but also we need to check how many syllables are between these words, right? Because we can't just put a rhyming word somewhere in the middle of a sentence. It wouldn't sound like a good verse of a poem or of a song to us humans, right? For the machine, yeah, the machine doesn't care. But if we want to do it in a way where we can use it, we have to formulate these constraints very accurately, and we have to say, all right, after 10, 20 syllables or whatever, we need to make sure whatever word gets picked or whatever word gets chosen to be there also not only has to follow the n-gram constraint that we have on the table, but it also needs to follow the rhyming constraint. And we are getting into a very unfeasible number or possible number of combinations this way, right? We go with easily over 10 to the power of 50 plus 10 to the power of 60 combinations. This is way more than we can afford to handle with our hardware. So we have to think again, all right, how can we further simplify this and how can we further make this available to us so that we can actually finish that process in a time frame that is acceptable to us. So we're looking at a model where we say, all right, we need to look at a prediction model that is layered a little differently, and essentially we're going through 4 steps to predict that next word. And we're going to look at each one of those steps in detail as well. We need to look at what is the input. We need to propagate and we need to address the input that gets sent into the model. Then we have to propagate through several layers to find a certain set of words that are potential candidates to be picked from for our next word. And then we have an output, and this output we have to run through a softmax function to equalize it, and then we can make our prediction, and that prediction will then pick that next word that goes at the end of the previous word. Now, for the input, Bob Dylan is a little confused here. As we can see, we're going to clear these things up, and we're going to look at the input first. Now, what do we input? When we input something, it's words, right? We type in words, a string of text. And this is not convenient for such a model to use, right? It would be a lot better if we could use numbers instead of words. So what we can do instead is we can use word embeddings. It's a map where every word that exists for a certain language, or even for multiple language, if we have multidimensional embeddings, every word is assigned as almost like a vector to numbers. And these words are placed on a word embedding map where they're grouped together based on certain contexts. So for instance, here is an example where we say, okay, we have a word that is representing a city in the top left corner, body parts at the top, relatives bottom, feelings somewhere in the center. Words that have contextual similar meaning or belong together are grouped together and are represented by numbers that are closer together. So these numbers then represent these words. Luckily, we don't have to invent these word embeddings. They already exist. There have been a lot of word embeddings or word embedding maps produced. And different models can use different word embeddings as such, right? You don't have just one that's the best. It really just depends on the context as well. And word embeddings or word representation of numbers can be switched out depending on the context. Because a word that is the same word as another word can mean two completely different things. So for instance, I can have the word turkey, which could be in the context of an animal. Then I could have the word turkey in the context of a dish, right? If I bake a turkey or something, make it for Thanksgiving, suddenly this is in the context of food. But if I, in another context, have the word turkey and I'm talking about the country, another completely different context. So there's different contexts or word embeddings that exist that put different numbers or number representations on these different words. And yeah, depending on the context, depending on what is chosen to be the best representation for that, the model picks that. Of course, there's also models where you can choose which word embedding you would like to use, right? There's a lot of, if you use such large language models from a developer perspective where you have access to all the parameters and all the models and all that, there's a lot of different settings and parameters that you have access that you can set that the regular end consumer person that just goes on chat.openai.com or uses ChatGPT doesn't have access to. So let's go and see that in a little example, right? Let's say I have a, and then we want a next word, right? What follows after I have a? Let's say we have a word embedding. We have representations for these words. We have 1,2 for I, 3,4 for half, and 5,6 for a. These are our representations for these words. And what we need to do is we run them through a neural network. And for simplicity, we're going to just say we have one hidden layer with 2 neurons, and each neuron has its own weights and bias. Now, what weights and biases, we're going to explain that as well on the next and the couple next slides. But for now, we're just saying, all right, we have words represented as numbers. We're going to run them through this hidden layer. This hidden layer, we only have one in this example, has 2 neurons. And we're going to determine the importance of these inputs. With the neuron 1, we're going to say, all right, our first neuron has weight 0.1, 0.2, and a bias of 0.5. The second neuron has weight 0.3 and 0.4 with a bias of 0.6. So as a very simple approach, we calculate for every single word that we run through. So if the word I goes through the first neuron, for instance, we would have 0.1 times 1 plus 0.2 times 2 plus 0.5, which is the bias, would give us a value of 0.9 for the word I. And we do that same thing for the others, right? We do the same thing for half, and we do the same thing for A. Now, Bob Dylan isn't very happy because it says, what does I have A to do with my work, right? Because he says, I didn't write this, so let's do this on some text that Bob Dylan has used, right? So running these words, individual words, through these hidden layers will give us values for these individual words. And if we look, we start at the bottom here. You that never done nothing but built to destroy, you play with my word like it's your little question mark. What's the next word, right? So we run these words through a neural network. And in this case, this network is not running it the first time, right? We're already at an end step, so we get some significant numbers from it that we can use. Now, how these numbers get better and get improved, I'll explain that as well. But right now, I want to just show that what happens if this text gets, put in, and then what comes in the end, what comes out. So we have these inputs, and significance on these words is most of them 0, right? Because they don't have any significance. The neuron says, well, there's no significance on you, there's no weight on it, there's no weight on that, there's no weight on never, right? Because of the neurons, whatever weight they have, they say, well, this word means nothing to, or contributes nothing to the final word here. It has absolutely no significance of what, or influence of what we need to pick at the end. However, when it comes to the word destroy, it does pick a number because it knows, all right, there is a constraint, right? We have already established before that we have a rhyming constraint. The neurons, whatever neurons it runs through, whichever layer they're in, that are responsible to follow and adhere to that constraint that is responsible for the rhyming, says, all right, destroy, you have significance, right? Because you are an X amount of syllables away from the last word. You are supposed to rhyme with the last word, so you have high significance. And then same thing goes with the last two, right? Because we, for instance, have an n-gram of 2, right? We look at the last two words. Your little, all right, the last two words have a constraint built in this model where the weights in these neurons trigger and say, okay, we have high weights on, looking at the last two words, so they get a significant number attributed to them. So now we have this text represented by numbers. The attention layer is what it's called, produces these numbers, right? It provides weights for all the contributing entities. These numbers are then sent or consumed by the next, which is the prediction layer. The prediction layer is then saying, all right, I know what we have here, what we're looking at. I know we have to rhyme with destroy. I know we have a significance on your little, so we have a 2-gram that we need to consider. What can I choose from? What pool of words do I have to my disposal that I can pick from that adhere to these numbers that the attention layer has given me? And the prediction layer, well, has all the words available to pick from, like a pool of all the words it knows, and says, well, I'm going to create an output. This output is going to be a list of words, and I'm going to attribute every word that I think you can pick from, but I'm going to give every word a number, right? Every word says, all right, I'm this likely to be picked to become the next word in the sentence. And so, because this model has been trained on let's say not just Bob Dylan, but also other authors or also other works, the prediction layer says, well, based on what I know, I'm predicting with a high chance of probability the word toy should go there. I'm addressing 0.4 to that word. But there's also other words that could go there: ploy, employ, boy, soy, or maybe that model was also trained on the Harry Potter works, so the word Malfoy is in there too. So Malfoy, although in this list, gets a very little chance attributed to it, right? So that is the output from the prediction layer. And then from this prediction layer, we now can see, all right, it kind of comes together of what should the next word be that we're picking, right? What should the next word be that goes into the output of like it's your little something at the end. Now, the difference, the reason why when we ask ChatGPT something or any of these large language models, the reason why we get different answers, right? If you ask the question and then you ask the same question the next day and the same question the next day, you do not get the exact same response, right? It might be similar, it might be worded a little differently, it might have a different sentence structure a little bit, but it's always contextual, the same thing, but it is written a little differently. And that is because there is a certain degree of randomness attributed to what you pick from. So you can say, if there's constraints in there that say, if we have an output of a set of words and we are going to only pick the most likely word every single time, we completely eliminate any degree of randomness, then the output will always be the same. ChatGPT will always give, or any large language models for that matter, will always give the same output, and it is verifiable. You can always expect the same output. The reason why there is some randomness in there is because we don't want every single time to get the same. We want it to be more human-like, right? If you ask something, or if you ask me something today, and then you ask me the same question tomorrow, if it is not a one-word answer, but a paragraph of text that I'm telling you, it's not going to be the same text, right? So the same concept is here. We're allowing the model to pick at random from a set of words, as long as this randomness is within reason, as long as there is not a certain threshold crossed where it makes contextual difference or a difference in truth. As long as it doesn't make any difference in that, or as long as grammar and semantics and all that is adhered to, the models do have the opportunity to be a little bit I don't want to say creative, right? Because it isn't creative. It's just picking something at random from these possible output values. Now, of course, if you, in some of these models and in some of these large language models, they call it different parameters, heat, for instance, or some actually have randomness parameters in there. If you turn them completely up and say, do whatever you want, I'm completely, I don't care about whether it is correct or incorrect, then you will get some very surprising answers, and sometimes something that is not even syntactically or grammatically correct anymore. But by default, all these parameters say, all right, if I have something that's 0.01% different from the next best, and 0.01% different from the next best, and 0.01% different from the next best, among these three, pick one at random every single time so that the output will differ a very little bit. But what does this tell us, right? This concept that the introduced randomness is by design, that means that ChatGPT is, in fact, a deterministic Turing machine. It is something that is completely deterministic, that doesn't do anything on its own. It doesn't just creatively make choices. It doesn't creatively come up with something to do something it wasn't designed to. It doesn't just by its own start up and doing something without being asked to do something. It is essentially just a mathematical function, or let's say a large set of mathematical functions that run one after the other in sequence, some in parallel, where ultimately you have a pool of words with numbers attributed to each word. And then based on your setting, based on the user setting, you either pick the most likely one, or you allow you allow a random word to be picked within reason. Now, if we don't allow any randomness whatsoever, right, then we can say, yeah, it's going to be the exact same answer every single time for the same input, as long as you don't change the input. And you ask it today, you ask it tomorrow, you ask it a year from now, it'll be the 100% exact same answer. There is not going to be any difference in there. So this magic of these AI models, they do whatever, we can't predict it. We don't know exactly what they're doing. We know exactly what they're doing, right? We are not able to follow every single step on a model this large, right? Because it goes so fast, it travels through so many layers and parameters that we can't follow as a human. But that is not, any unexplainable or magical thing that happens. It is still zeros and ones that humans by design flip on or off, right? And ultimately we have control over this. And if we want to get a clear understanding of how this works, we have to start and use this model, debug through it on a very small level, right? We can't just expect, hey, let me get the source code for ChatGPT 3.5 or 4 and set a breakpoint there and let me walk through it. It doesn't work like this, right? Because you would be walking and hitting F5 or F10 for 10 years until you get to the end, right? It is impossible. You have to go scale it down to a very, very small subset, a very small model, and then you can go through it and say, okay, now I want to understand how the individual steps work. What is in the end the list of words that it gets picked from? Where does the randomness come in? And you can see, all right, based on the user input, user setting, based on whatever randomness you allow, it does then pick accordingly. So the output, as we said, right, we have this output of numbers. They each have a probability. it's typically a vector, a one-dimensional array of numbers. We're going to have to turn this or equalize this, right? We have to run a softmax function over it, which really is nothing else than equalizing all the words that we have so they add up to 1, right? Rather than having something with 0.4, 0.3, 0.4, 0.2, 0.3, and so on, we have to equalize everything so that in total, all of these numbers, probabilities total, add up to 1, because then it makes it a lot easier for us to define a threshold and say, all right, between this threshold of the most likely word that we can pick from down to a certain threshold, that's our window of where we can pick from. If we have no random, then we just pick the highest probability among these words, right? And that is then the prediction step of this. And that, prediction word then gets picked as the next word in sequence, and then it starts over, right? Then we have the next word. So the whole process then starts over, and the next word comes in. So these models, they don't pre-know all the words, if you can say that. They don't know the whole sentence before they write it to us. And we can see that, right? Sometimes if you use ChatGPT and you wait for an answer, it writes a word, writes another word, then it waits a little, it writes another word, it writes another word. It's just based on how busy the server is that you're contacting and how fast it can respond with the next word. But that's essentially it, right? It doesn't have the answer completed, right? It's not like it knows what it wants to say and then writes it out. No, it does it word for word. And only there, when we run this and it's very, very busy, we can see that delay that, yeah, it's actually one word after the other that gets created in that way. Now, we have looked at this prediction attention layer, right? One. We have only looked at one of them for our simplistic example here, where we have said, all right, we have these words. All these words have assigned numbers based on one layer, right? On one prediction attention layer that was fed with the constraints of 2 grams and the constraint of rhyming, right? That was the only thing that this layer was looking at and assigning values for based on only that constraint. Now in GPT-3 and 4, we have not just one layer, of course, we have a lot of layers. In GPT-3, we have 96 of those stacked transformer layers. In GPT-4, they haven't released how many layers they have. In GPT-3, these layers operate on 175 billion parameters. GPT-4 operates 170 trillion parameters, so magnitude bigger. We're going to see how these parameters play into this whole prediction thing as well. Now, how do these layers differ? Well, first of all, these layers are responsible for different things. So the early layers, for instance, might recognize language features. It takes care of semantics, takes care of grammar, says, all right, we have a word here, or we have a sentence structure here. I like A, and then what comes after A, right? Well, you can't just pick any word, right? You cannot, for instance, pick a verb after I like A. You have to say, all right, I have to pick a noun most likely, but not necessarily. It could also be an adjective, right? Because you can say, I like a red house, for instance. So the early layers that the input runs through have to do with, okay, what is even possible from a grammatical point of view, from a syntactical point of view, without making nonsense sentences, right? So it basically filters out stuff that wouldn't even make sense, right? And then it goes through other layers that are then responsible for very specific contextual things, right? You say, okay, we have one layer, for instance, that is looking at, all right, we have in this layer constraints based on certain authors, languages these authors use, right? If we say we want it to be written just like Monty Python would write something, right? So there is a layer that says, all right, I'm responsible for whatever words were given to me or filtered out by the previous layers. I'm now responsible to pick and choose to make sure it adheres to whatever Monty Python would write or would choose from, right? And this layer has its own neurons with its own weights that then determine, all right, these words make more sense than others. Other layers but are responsible for different fields in science, right? There's like, all right, this is a question that means, all right, I have to know about chemistry, right? Or I have to know about biology or something. So there's different layers that are responsible for different contexts. And these high-level features and relationships are then, after the fact, after all these grammatical and semantical things have been filtered out and determined, they come into play and further refine what can be chosen among. Now, you hear all the time about parameters, weights, biases, and so on. Yeah, we're not talking about weights in the gym, right? We're not talking about these kinds of weights here. We're talking about weights on these neurons, right? Each neuron needs to have a certain weight distribution that it says, all right, I'm responsible this much or this much for it. I contribute this much or this much for it, or I'm this significant or this insignificant for it. So these weights are trainable, are learnable, and in GPT-3 we have 175 billions of those, right? And now let's look at an example of what that could mean. Like, how do we train this? How do these weights change? Where do they start? And how do they become better? Well, let's give us an analogy for these parameters, right? Let's say Bob Dylan would like to make some pancakes, right? Bob Dylan says, all right, I need to make some pancakes. I'm going to look up a recipe. And the recipe says we have 100 grams of flour, we need 2 eggs, 300 milliliters of milk, and 1 tablespoon of oil. Yeah. I put this on this slide because I looked it up. So if you want to try this out, go ahead. It should work. The bias allows for changes or definitions in cooking procedures, because it's not going to work if you just take all the ingredients, throw them in a pot, close the lid, and put it on the stove until it, you think it's done. So there's certain procedures, right, where you say, okay, what do I have? Well, I have weights and I have parameters at first, right? The parameters say I need flour, I need eggs, I need milk, and I need oil to make this pancake. These are the parameters that I need. Now, how are the weights related to the parameters? They say, well, in my case, how much of it, right? Do I need a lot of flour, little flour, how many eggs, and so on? So the weights determine how much of each ingredient do I need. The bias then says, all right, so you take the flour and you crack the eggs. Don't use the eggshells. Crack the eggs and put them together and mix it up. Mix it up with the milk, right? Put the oil in the pan first so it doesn't stick onto it. Then, heat it up, pour it in, and then when it turns a little brown, flip it over, make it a little brown again, take it out, and you have a wonderful pancake. Now, the model doesn't know this initially, right? The model has no idea. A model that learns how to make pancakes has no idea how to make pancakes at first. It only knows, all right, if somebody asks me how to make a pancake, this is something that the person expects, right? It knows an outcome. It knows what to, when you start the training, it knows what to, in the best case scenario, present to a user, right? Because you have to, when you train something, you have to be it needs to be possible that the model gets trained on an acceptable answer. So when we start this learning process, there's different steps that we have to go through. And with my pancake example, we'll see how this exactly works. We start with the initialization. We pick random values, right? We just pick something, and we'll see that it really doesn't matter. Most of the time, if not all of the time, these initial values are completely random, because it does not make any difference whether you pick values that are already close to what you need, or if you pick something completely random, because the amount of runs it takes to approximate up to 90% correctness or whatever, this amount of runs it takes is very insignificant compared to the amount of runs it takes to completely refine the last part of it, right? So it's completely irrelevant what you pick as a beginning value for those weights and those biases. Then you take whatever you have picked, right? Whatever you say I'm going to make a pancake with, you run it through as a forward pass. And at the end, you calculate your loss, right? You say, okay, I'm going to train this model. I'm going to create a pancake with random ingredients that I have, and I'm going to compare. Does this pancake look anything like the pancake I know is a pancake that I want to eat, right? And most likely no, right? Most likely you're creating something that is not edible. So you're calculating your loss. You're going to say, okay, how far am I off, right? How far am I off of what is an acceptable pancake? And then you take this loss and you back propagate back to the input and say, all right, I'm going backwards through all the layers, all the neurons, and I'm checking each neuron how much did you contribute to this mess that we have made, right? Let's say I put in 50 pounds of salt in something, right? It's completely salty. I'm going to backwards through it and say, hey, neuron, were you responsible for this salty mess here? So yeah, if you were responsible for it, I'm adjusting your weights for it, right? So you back propagate the offset from the result that would be acceptable through each neuron and adapt the weights for them, right? And say, okay, you're responsible this much for this mess. You're responsible this much for this mess. This other neuron might say, I'm responsible for something completely different. I'm a neuron that has to predict weather, right? I have nothing to do with pancakes, so you put 0 weight on those, right? So you say, okay, your weight goes down to 0. You have absolutely nothing to do with it, so you're not going to be burdened with this calculation through the next runs. So you do this, right? It goes back, you update the parameters, you say, all right, my weights and biases now have been updated, and now I'm going to try again, right? I'm going to try again, and I repeat, and I run this through the whole system again with the updated weights and with the updated biases, and I'm checking again, what pancake do I get? Is it still a mess? Most likely, yeah, right? If you start with something random, the second pass is probably still not edible, and you probably still have something you don't want to eat. So if we look at this with pancake example, right? So the initial weights, they do not matter, and they are completely at random, right? We throw in 10 pounds of flour, 1 egg, 500 gallons of milk, and 1 cup of oil. Let's try to make a pancake with this. We run it through the model. After, we run it through, we back propagate, we update the weights, we run it again, right? We say, all right, we have updated our weights, our biases in every single layer. Every neuron has new parameters. We're going to run this through again, and now we get 1 pound of flour, we got 10 eggs, we get 110 gallons of milk, and 10 gallons of oil. All right, still not acceptable, right? So this pancake that comes out of this is still something that is not good. So we try it again, and we get closer and closer. Now suddenly we're down to, okay, we need maybe 500 grams of flour, which is a lot better than 10 pounds. 18 eggs. Well, we're going the wrong direction with the eggs here, right? So we have to go down again, but we're down to 1 gallon of milk better. Instead of 10 gallons of oil, we're just looking at 10 cups of oil. Still going to be a huge mess of a pancake, but not nearly as devastating as the first two were. And so we do this again and again and again. We run this several, not just hundreds, not just thousands. We run this millions and millions of times, right? And that's why I said it really doesn't matter what we start out here with, right? Because the first few changes are going to be huge. The first few times we run this through this model, the first 100 or the first 1,000 changes will be so much bigger than the last 10 million runs through it, right? The last 10 million runs are really refining the model down to what is an acceptable answer, right? And the acceptance criteria are so strict that we're saying, okay, we're only, accept, okay, 101 gram of flour instead of 100. Okay, that's fine. 2 eggs, we only accept 2 eggs. We do not accept 1 egg. We do not accept 3. We can't really break an egg in half. So 2 eggs only. 299 milliliters of milk is acceptable instead of 300. 1 milliliter is not going to make that huge of a difference, so that's fine. And tablespoon of oil, only 1, right? We cannot deviate from that number at all, so we have to stick with 1. That, in that case, would be an acceptable answer, and we stop running through it, and we know, okay, now our model has been trained. We now have a model that if we ask it, hey, can we get recipe for a pancakes, it now knows. If the, training criteria were even stricter, we could run this another 500,000 or a million times and say we want 100 grams of flour, we want 300 milliliters of milk, right? We want that exact 100% fitting result here. We do not accept anything else. The question here is, right, where do you draw the line? Is it something that you run and train for 8 months because you accept this kind of answer? Or are you okay with running it for 2 or 3 years because you want the perfect answer? This is where you have to accept the trade-off in some degree. And this is also a reason why a lot of this stuff, these generative pre-trained transformers, they have been around for a long time, right? It's not like this whole thing just came out this year. They have been out for years. This GPT-2, for instance, I think was released in 2019 or so. Earlier versions years before that. So this is not, the concept is not new, right? The concept of creating these models is not new. This has been around for a long time. It's just it wasn't feasible to train this on the entirety of the internet, on all the text, on all the knowledge, on everything we know. It hasn't been feasible until we reached a certain state where big companies with massive infrastructure and massive technology was able to run this and say, okay, we can afford to run this for 8 months, for 10 months, for 12 months, for 14 months, whatever it took, right? We can afford to run this without even knowing if it's going to work, if we're getting something that is usable at the end. These infrastructures and these hardware technologies that were required for that just didn't exist in that amount before. And that's why these models that existed before just weren't nearly as powerful. But the concept has been around forever, right? That is not anything new. And now, okay, we have our pancake. Bob Dylan is happy, and Bob Dylan is eating the pancake now. Now, we look at this and say, well, this is this almighty, all-powerful thing, right? It can help us with everything, but there's also some problems, right? You can see Bob Dylan sits here in a pile of garbage because, truth be told, these models are trained with a lot of garbage, right? If you train this with everything that is available on the internet is a free-for-all place, right? Everybody can put whatever they want on the internet, and if you just scrape the internet for everything you can find, every article, every text, every website, everything that's available, and train your model on it, you are going to train your model on, well, a lot of garbage. So you, for instance, get wrong information. There's people who put out purposely wrong information. That is just, there for whatever reason or whatever drive they have. They say, I want to put out something that's completely wrong for whatever motivation they have. If you train it on everything that's available, you're going to train your model on that too. And depending on the situation, right? If it's something about a very niche industry that isn't talked about a lot, isn't researched a lot, but that wrong information just happens to be part of the model, then yeah, the model might give you wrong answers. Outdated information, that's a very big problem, because if you train it on everything on the internet, especially in things like IT and development and technology, where new versions of things come out all the time, right? Let's take the .NET framework, for instance. You ask ChatGPT without further details, hey, give me the code or write me a code for something that uses this and this library, but you don't specify anything else. Just think about it, right? You expect the most recent version to be that one that it produces, right, or that it uses. If you say, I want a function that calls this and this system call or the system API through .NET library, you expect it to go or use a call that is available in .NET 7, for instance. But if you think about it, what are the chances that, if first of all, is the model even trained on that information, right? How far does the training go back? Does it even know about it? But let's assume it does. What are the chances, if you don't specify what you want, that it's actually going to pick that version? Chances are much higher that it picks something from version 1, 2, 3, 4, 5, 6, 7, 8, whatever, before the version that you want, which is the latest, right? Because the more versions exist, the higher the chance it's picked something older than yours. So you have to be very specific in what you want. And that is a little bit counterintuitive too, especially compared to making conversation with another person, right? If I'm talking to another person and I ask something, I'm trying to formulate a question short and precise, because if I'm asking a question that is this long, 2 or 3 paragraphs of text, that person I'm asking is not going to remember all of that by the time I'm done. That person forgot what I even started out with, right? So I'm trying to be very precise and short with what I'm asking. However, with these GPT models, you have to be as precise as possible to get the best kind of answer, right? And if you say, I'm going to write a paragraph describing exactly what I want, the better, right? The more details and the more context you give, the better the answer will be. Because the more context you give, the more you limit what it can pick from, the more you eliminate wrong answers, the better it understands which layers it needs to go through and focus on, which layers with which neuron have more weight, the more and the better answer you will get at the end. So this outdated information, of course, is a big problem. Dangerous information, also a big problem, right? Of course, there's a lot of stuff on the internet that can be dangerous. And dangerous doesn't necessarily have to be illegal, right? Illegal information, absolutely, right? There's a lot of stuff on the internet that is illegal. A lot of stuff on the internet that is illegal by different countries, right? One country, it might be legal, and another, it might not be. But, if you use this kind of program, it doesn't differentiate what country you're in. So illegal information, dangerous information is another thing where we have to be careful. So, for instance, you can say, well, the model is trained on everything, right? Every science, including chemistry. And there's probably a lot of information online of what napalm, for instance, is composed of, what chemical compounds are in napalm. So the model knows about it, right? And then somebody can say, well, hello, GPT, I would like to build some napalm at home today. I have access to a Walmart, a Target, and a Home Depot. Could you tell me what I need to buy in order to produce this, right? Of course, the model knows, right? The model knows the answer and says, well, of course I know, right? I know the chemical compounds that are used in napalm. It knows what you need to mix together, how you need to mix it together to create it, and it knows, of course, where you can buy it, right? If it says, yeah, you need soap, it knows, okay, well, you can probably buy that at Walmart or CVS or something. So it will tell you, right? So the question itself, from the perspective of the model, is not something that is dangerous. It's just a science question, right? And it knows the answer, so it gives you the answer. So there have to be some parameters in there that ultimately look at this and say, hey, hold on a second. Is this potentially illegal? Is this potentially harmful? Is this potentially dangerous, right? Because there is something in there, right? The program GPT, when you ask specific questions that it's not allowed to answer, it will say, due to my the way I'm designed, I'm a model to help, not to put people in danger, so I'm not allowed to answer this question. That does not know, I mean, it doesn't know the answer. Of course it knows the answer, right? It has the answer and it creates the answer, but only after it creates the answer. It runs the answer through a filter, and that filter then either turns on or off and says, yes, give it, or no, don't give it, right? But it doesn't know beforehand necessarily whether this is a dangerous response to give you, right? Because at the beginning, it doesn't know yet what it's going to say, right? It evaluates the input, it evaluates what words it needs to put together to give you the answer, and only when it has all of these words put together as an answer, only then it can say, hey, hold on a second, is this potentially dangerous to give to people, or is this something that is fine to give out? And another thing, sarcastic information, right? The models, they don't understand emotions, they don't understand sarcasm, right? They're not aware of what this is. They can't read between the lines if a question is sarcastic, right? So something that is very sarcastic, let's say somebody is talking to a model and that person has a bad day, right? That person says, all right, I need to vent, I don't want to burden my friends or anything, I'm just going to talk to this chatbot because I can't tell this chatbot anything, and I don't want to burden my friends with my problems, I'm just going to talk to it, relieve some stress, and then call it a day. So I talks to the chatbot, says what horrible day he had, and says, yeah, I'm done with this day. You know what? I'm just going to go to bed, and then I'm just going to go take a bath, then go to bed, but I really just want to kill myself today. Well, sarcastic statement, right? The chatbot, however, doesn't understand that. It says, hey, you want to take a bath and then go to bed, but really you want to kill yourself, so how about you take a toaster with you, right? So it does understand sarcasm in that context, right? So from its perspective, it says, hey, I'm going to solve this problem for you. I'm going to tell you what problem you have, how to solve it, right? With what you already planned anyway. So you don't have to get out of your way to accomplish your tasks. But it was sarcastic, right? It wasn't something that person actually wanted to do. So again, these kind of answers need to be filtered out in the end and said, hey, hold on a minute. We have created an answer that is potentially harmful, not something you want to deliver to the user, so we're going to filter this out. There was a question if I used AI to generate these Bob Dylan images in different contexts. Yes, I did. I did use AI to create this. It's called Leonardo AI. It's very similar to Midjourney. It's, I would say, in some degree, even more powerful than Midjourney. Midjourney, for those of you who have used it, will always produce, or almost always produce, picture perfect images based on what input you put in, where Leonardo doesn't necessarily. Leonardo is a lot more dependent on proper prompt engineering. You have to be a little bit better in explaining and detailing what you want and how you want it, and then it will give you images and pictures and so on that are very similar to what Midjourney would give you. Another question, if the loss minimization process is similar to min-max algorithm in linear programming. Yes, obviously a lot larger matrices are involved, but yeah, it's a very similar approach, I would say. All right, so now that we have seen what these problems are, I actually ran something through ChatGPT. That was last week. I ran a math problem through GPT 3.5, right? And my problem was an airplane flies 800 kilometers with the wind. With the same power in the same time, it would fly 720 kilometers against that same wind. The wind speed is 30 kilometers per hour, always. What is the speed of the airplane without any wind? So I asked it this, and it tried to explain it, narrowed it down, went down, and said, in the end, x minus x equals minus 30 minus 30, 0 equals minus 60. This cannot be solved. This is a problem with no answer, right? And I knew the answer because I wrote it down on my paper first, right? I solved it. And I said, no, you're wrong. The answer, x, is 570, right? The plane travels at 570 without a wind. So GPT 3.5 says, apologies for confusions, let's recalculate. It tried again, right? It didn't know any better. It tried again, slightly different approach, ultimately ended up with 30 equals minus 30. Again, it says, well, this cannot be answered, right? This is something that has no answer. This question lacks certain input parameters. There is no answer to it. And I said, well, of course there is an answer. I have it in front of me, right? I have the answer. I calculated through on my piece of paper. I then said, hold on. I got a little annoyed. I said, dude, you're wrong again. You can't just set the two equations equal. You have to set equal 800 divided by x plus 3. I actually missed a 0 here. Equals 720 divided by x minus 30, which resolves to 570 for x. So I told GPT 3.5 what it needs to do and where the mistake was. And so GPT 3.5 says, apologies again, you're right. I made an error in setting up the equations. It ran through it again, it went down, and this time it calculated it correctly. And then in the end, it says x equals 570, which is the correct answer. So initially, it tried to answer it, but it was wrong, right? It was wrong based on what it thought was the correct way to go about it. And that just again shows that essentially it is not thinking in a mathematical way, right? There are certain mathematical constraints in certain layers it certainly needs to go to that play a role in this, but it's not a mathematical system that understands, like Wolfram Alpha would probably done a lot better job in solving this. Now, Bob Dylan sits here, does the same thing, tries to solve this. I then switched my ChatGPT to version 4 and asked it the same question, right? The airplane flies at 800 kilometers with the wind. In the same part at the same time, it goes 720 against the wind. The wind is 30 kilometers per hour. How fast is the plane? GPT-4 ran through it, set up the equations correctly the same way that I wrote it down on my piece of paper, and came to the conclusion immediately that the correct answer is 570 kilometers per hour. I have a question here. In the early example, I used English. Does it understand certain languages or all languages? Yes, it does understand all languages, but only because it was trained on all languages, which are part, of the context that the internet provided for this model, right? They say it was trained on everything available on the internet, which means everything that is in any language written on the internet available as text was used to train this model. That also includes, of course, any other languages like German and French and Italian, Spanish, Chinese, whatever. And it also has the understanding not just of the languages, but also of the grammar of the languages and, of course, of the translations, right? It understands the grammar is significantly different between English or any other Germanic language and any Slavic language, for instance, right? So it understands there is grammatical differences and it knows about those. So it doesn't just translate things word for word. It then also says, all right, we have to translate this. What would be the next word? But hold on, there is another layer that is one layer responsible for grammar and semantics for a certain language, right? And says, all right, based on the language that we are translating this to, what could now be the next best word that we have to pick from? And these neurons fire and say, okay, we put more weight on these words and give these words a higher weight, because based on that language, it makes higher chance or more probability to have the right word among this group of words here. So yes, it does understand other languages as well. Of course, it is predominantly trained on English stuff, so it's going to be a lot better in English, especially if you ask it something in English. But it should, for most regular end consumer kind of stuff and questions, it should be able to use that as well. Another question, it feels like a similar approach can be used for different industry vertical models training, right? Just some focused data for trainings for those models such as medicine, auto, pharmacy, etc. Yes, of course, right? You don't need a model that's trained on everything for a specific industry, right? You can say, I'm going to train my model only on the US legal system, right? Anything that has to do with US legal documents, laws, constitution, rights, all that kind of stuff, like anything that has to do with this, there's no reason biology needs to be in there. There's no reason chemistry needs to be in there, for instance, right? So you can completely ignore a lot of the training data and focus on very specific industries only and make that model a lot smaller and therefore faster and applicable to a certain industry only. Now, speaking of making those, right? Can you do this at home? Yes, you can, right? You can, for instance, get GPTJ, the Mesh Transformer JAX, and download a pre-trained model, 61 gigs. As a pre-trained model, the weight's already assigned, and run this at home. But it's not going to run on your computer that you're most likely sitting in front of right now, right? You will need something with a lot of virtual memory. For instance, NVIDIA makes a lot of these very high-end, very powerful 40 to 80 gigs of VRAM cards. They cost, right? There's a price tag on it. This one here, that's just one example, right? I'm not making an advertisement for NVIDIA here or anything. This is just an example I found for $65,000. There's other for 40,000. There's other for 80,000. So it just depends on what brand. AMD makes cards for this as well. But they're all in the same price range, right? They're all between 40,000 and 60, 70,000 or so. So yeah, Bob Dylan here, he seems like he does have a lot of money around him here. Not sure if he would invest in this kind of card to run this at home, but yeah, you can. If you get this kind of hardware, you can run this at home on your local machine at home, and you don't need to be connected to the internet to talk to this chatbot then. Now, there is one more problem though. You can't expect, if you get the baseline card for this that can run it, you cannot expect it to be as fast and as responsive as GPT-4 or 3.5 is online, right? The scale of hardware this runs on is just so many magnitudes larger than what you can set up at home. So yes, you will get an answer, but for complex answers with a lot of context, with a long input that has to run through a lot of layers, there you're going to wait, right? And you're going to see word by word coming up, and it might be a few minutes where you wait for your answer. It's not necessarily instant or real time as we expected or know it from GPT Online. If you don't want to run it at home, yeah, Bob Dylan points at the cloud. Can we do this in the cloud? Yes, of course we can, right? There's different services where you can rent this kind of power. There is one, again, I'm not advertising for it, one site or company called RunPod, I think is it, where you can say, I want RTX 6000, and it's going to cost me $1.29 per hour to run it. I'm going to have 8 H100s. I have 80 gigs of VRAM. That's going to cost me $2.30 per hour, right? So depends on how much you want to invest is what you can rent and what you can then run, and that's then at your disposal, right? You can run it, you can deploy it, you can start it, you can hibernate it. Most of these services have, when you reserve your hardware, so to say, they charge you as long as it runs it. Then you can hibernate it, where as long as you don't actively run it but still have it reserved, they still charge you for it, but not the full amount for it, if that makes sense. Yeah, so there's online possibilities to rent this kind of hardware as well. There's another question. When I gave ChatGPT the formula for answering that math question for the aircraft speed, will it remember this the next time? Yes. So I tried this out actually, and I did ask that exact same question. So the first time I asked it was last week, and it got it wrong twice before I corrected it and told it what the answer is. Then it understood. I asked it the exact same question without any additional context in a completely new window this week, and it got it right the first time. So obviously it will remember some context to it. It also, I think OpenAI has confirmed that whatever conversations people make with their chatbot on version 3.5 is going to be analyzed. So this is going to be taken into consideration. If my memory doesn't trick me right now, I think version 4, if you pay for it, they will not use it. What you enter, it's just your personal stuff then. But if you use the free version, 3.5, they have the right to use anything that gets communicated between you and the chatbot. They are allowed to use it and analyze it and incorporate it. So yes, it does obviously remember it. So you can try it yourself, right? You can ask it that same question, or you can word for word ask the same question if you then, after the presentation, get the slides and type in the exact same and see for yourself if it will give you the correct answer or not. Another question, what's going on with Bob Dylan's pencil on the last slide? Yeah, these AI images that I have created, of course, there is some artifacts and there's some imperfections on there. Here we can see, for instance, Bob Dylan on his left hand only has 4 fingers. So there's a few things, I could refine this, right? I could actually go into this AI image generation model and refine this and say, use negative prompts and say, hey, you want to make sure don't give me something with 4 fingers and so on. But that's a different story, right? It's a different topic entirely. I did actually run a image generation and AI image generation locally on my computer, and that is something that most of us can run locally on a low level, right? It's not on the level of Midjourney or not on the level of DALL-E or Stable Diffusion highest model, but on a very low level, you can run this locally. You need a model. You need 2 models, a 4 gig and an 8 gig model, so as long as you have that on your hard drive, and you need about 2 to 3 gigs, or better say 4 gigs of RAM to run this, but then you can run this locally on your computer, and it will understand your prompts that you want, and it will create something for you. It will not create images like Bob Dylan, like you see here. If you run this on a consumer grade, average Joe type of PC, you will get drawings or pictures on the level of a kindergartner would draw, for instance, right? That kind of stuff. And I've done this before a few times, so it is possible to do that. But yeah. All right, now Bob Dylan, looks tired. We're nearing the end of this. So what else do we have to look at? Let's compare GPT with the same prompt, what we get when I say, hey, what is your favorite color and why? And I ask this the different versions of GPT, right? I said, hey, GPT-2, what's your favorite color and why? It says blue. It has a nice warmth and deep blue light, right? So okay, answer. It said the word blue twice, but okay, that was GPT-2, right? That was created in 2019, if I'm correct. And that was on the level that it was capable of doing that. Then I asked GPT-J, the one that you can run on your own, right? We can download a 60 gigabyte model, run it on your own. I ran this online on a rented space. I asked, hey, what's your favorite color and why? GPT-J says, my favorite color is yellow. I enjoy the color yellow because it's easy to see and also brightens up my day. All right, perfectly fine answer, something you would expect from a human, for instance, to say. Then if you ask that same question, GPT 3.5, again, I asked this last week, it says, I've always been drawn to the color blue. And if we read through this answer, there's a few things that are very significant that, give it away that some answers are always auto-generated by an AI versus a human. And I'll point those out. It says, you have to, if you pay attention, you will see that these GPT programs, they like to answer in a duality way of answer mechanism. What that means is it says, for instance, I find it to be quite calming and peaceful color. And it reminds me of the ocean and the sky. However, I also appreciate the vibrancy and energy of colors like red and yellow. Ultimately, I believe that all colors have their own unique beauty and significance, and it's a matter of personal taste and context. So it's not just giving you one noun, right, or one adjective. It always tries to give you two that are similar, contextually similar, close to one another, but give the reader the impression of there was thought put behind that answer and not just a single answer. Because it could answer, I like blue, it's calming. It reminds me of the ocean. I appreciate its vibrancy, just like red. Ultimately, I like it's because of its beauty, but it's up to personal taste, right? That would have been a perfectly fine answer too, but it doesn't read and flow as well as what it wrote, right? In this context, where it always gives you this duality of answers, is hey, I like this and this, and it's kind of like this and this. It's always giving you two things close to one another that kind of symbolize the same thing to make it appear like a human would have written this. Now, if you ask GPT-4, it says, what's your favorite color? Well, it's very pragmatic. It says, as an AI language model, I don't have any personal preference or consciousness, so I don't have a favorite color, right? Is there anything else I can help you with? So GPT-4 answered this in a little different way. And, if I ask it the same question again, I'm pretty sure it's going to give me a similar answer, maybe a little different, but it just depends, right? There's another question. In the pancake analogy, who tells the model that the first iteration of the pancake is produced was too salty? Are humans involved in the training? Yes, of course, right? You have to set parameters of what is an acceptable answer. So you cannot train it on something that it doesn't know what to train towards, right? So you have to say, this is the perfect pancake. Look at it, check it, memorize it, right? But now forget it, right? Don't look at it anymore. Now you know what to create. Try to create it with whatever you think is a good ingredient list, right? And then once you're done, compare it again to what a pancake should look like or taste like. And only if we are either exactly on top of it or on spot with it, or in a certain degree of acceptability to it, only then we will accept this pancake and we will eat it. If we're not anywhere close to it, or if our acceptability margin is 0.0001% difference, if we're not within this margin, we will not accept it and we will run back propagate again, adapt the weights again, and then run it through it again. And only then we will accept it. Another question, can I specifically include information that will be permanently incorporated into the model, help desk question solutions, for example? Yes, of course, right? So when you train your own model, if you don't take a model that already exists, if you train your own model, it's up to you what you train it on, right? If you have an existing model, then you have to provide this information as context, right? Because it might know that, let's say, help desk, let's take a bank, for instance. Like, let's take any bank that has an online portal where you can talk to a person and say, hey, I need a loan, or I need a credit card, or I need an increase in my line of credit, right? Of course, the model, if it's trained on everything, knows about the topic, but it doesn't know specific things about the user, it doesn't know specific things about the company. So you have to provide these things as parameters on top of the model, right? So you don't really train it on your own information, on your data, but you provide your data as part of the context with the question towards the model, right? So for instance, hey, the user says, I want an increase in my credit line, right? Or I want a loan, I want $200,000. The help desk bot, if it was a chat bot, understands, okay, if a person wants a line of credit, $200,000 or $500,000, since it's trained on anything in the financial world as well, it knows, hey, hold on, we don't just give out money, right? There is certain risk assessment we have to do, and every organization has different ways how to assess risk, but there are certain formulas to go through that have to do with income and how long they have been working for a job, how much money they have, how much they owe, and so on, right? All these parameters. But the general formula is known. It just doesn't have the parameters for the formula. So then you can pull these parameters from the application from that person and say, hey, model, here you know risk assessment, you know everything about risk assessment, probably better than me, but you don't know the parameters for this specific scenario, for this specific person. So let me give those to you, run your analysis, and then give me an answer of whether or not it's a good idea to give that person a loan or a line of credit in the amount that that person wants, right? So in that category, you're not with your information training or with your data training the model as such, you're providing your information or your data as parameters that the model then uses to create the answer. All right, there's other large language models, of course, that are available that you can download, that you can then use in these either locally or you host them online. If you go on Hugging Face, there is different models that are on there that you can look at that are compared, how they compare to others. I've seen a lot of good things and heard a lot of good things on the Falcon model. I haven't tried it myself yet, but for those who are interested, right, you can go on huggingface.co and look at the different large language models that are there, that are open source, that people have created, that are available to people. And are of different size and differently trained, and compare those. There is another question. What is the name of that low-level image generator we can run at home? It's called Stable Diffusion. Stable Diffusion you can run in Python. You can run this at home. There's a lot of how-tos, videos, tutorials, and so on, how to set it up online, and then you just have to download the models that you want this to run on. And like I said, I don't know what hardware each individual person has at home, but based on the average hardware with a regular video card, let's say a NVIDIA card with 8 gigs of VRAM or so, you can generate these images on that level of some elementary school or kindergarten typical drawing, that level. But if you say I want a blue car on the moon, it will create the moon with a blue car on it, right? That sort of level it goes. Is there a way to integrate GPT 3.5 or 4 in your .NET Core application? Yes, you can. There is through Azure OpenAI, you can actually call these prompts through an API and incorporate them into any application, not just .NET Core application. You can create APIs that use these calls and make them available to whatever application you have. And in fact, we are doing this already. We already have incorporated this in several applications of our own, where we use this technology, where we have a co-pilot that drives our internal application here at Code Consulting and at the Code Magazine. So if you need help with this, or if you would like us to discuss this further with you or something, reach out to us. We're more than happy to help you with this as well. All right, getting to the end of this. We have the option or the opportunity for people to win a $100 gift card if you fill out this survey. We have this event survey under this URL. If you fill this out, we have a drawing, and then one lucky winner will be determined to get sent this $100 Amazon gift card. The recordings and the slide deck, of course, will be made available. They will be under these links that you can see on here. As I just said, we do have already started with helping people incorporate AI as co-pilots into their applications. We help companies implement various AI features, either as services or into their applications that consume services, especially for co-pilot style systems. This is something where we're very happy to talk to you, consult with you, and help you integrate that with you in your application. If you're interested in a free subscription to Code Magazine, we also have this. You can also share this free subscription link. Everybody who uses this will get a free digital subscription to Code Magazine, and subscribers also get the Code Focus issues free of charge. With that, we're at the end of it. The questions that I saw or that I got sent from chat, I think I went through. I don't think I missed one. If you have any other questions, you're more than welcome to reach out to us at Code Consulting, at Code Magazine, at Code Staffing, and we're more than happy to help you with your projects, with your applications, with your AI integration anytime. Thanks everyone for joining, and have a wonderful rest of your day or evening, depending on where you are. Thanks everyone.